For this lesson, we're going to be continuing on with trigonometry, and we're going to be looking at right angled trig. So what we're going to talk about today is really one of the most significant rules in trigonometry. So again, everything we're doing today only applies to right angled triangles. So if you don't have a right angled triangle, you either need to cut it up into right angled triangles or use a different property. So one of the first things we do when we get a right angled triangle is we have to label it. So here's our example of our right angled triangle. And we know it's a right angled triangle because we have this right angle right here. And how we label it is we start by finding the hypotenuse. And the hypotenuse is the side directly across from the right angle, and it is our longest side. And we will be identifying our hypotenuse with an H. Next, we will be having an angle that we're either given or that we're looking for. And we always circle that angle. And then the side that's right beside my angle is called my adjacent side. And adjacent is basically just a fancy way of saying right beside something. And we'll be noting adjacent with an A. And our last side over here is directly across or opposite from the angle we're either given or we're looking for. And this is referred to as our opposite side. And we'll be denoting that by an O. And we're going to go through and practice with these so you get used to labeling them. So once we've labeled our triangles, we need to be able to use these side lengths and our circled angle in order to set up some equations and find different values. So these equations we'll be using are called the three trigonometric ratios. And basically what they do is there's a relationship between my side lengths and my angles. And these ratios or equations use that relationship in order to find angles from side lengths and side lengths from angles. So to do this, we'll be using the sine, cosine, and tangent of an angle. And those are those buttons on your calculator that say sin, cos, and tan. So when I'm looking for the sine of an angle, I'm going to divide the length of my opposite side by my hypotenuse. And as an equation, I write that as the sine of my angle, and we write a big X for our angle, is equal to my opposite over my hypotenuse. So that's our first equation that we need to know. The next one is the cosine of our angle, and the cosine of an angle is equal to the length of the adjacent side over the hypotenuse. And how we write that as an equation is the cos of our angle is equal to my adjacent side over my hypotenuse. So that's our second important equation. Thirdly, we have our tangent of our angle, and that is equal the length of our opposite side divided by the length of our adjacent side. And how we write that out as an equation is the tan of our angle is equal to our opposite side over our adjacent side. So we have three equations that we need to remember. And how we remember them is by using this term, SOHCAHTOA. And it sounds silly, but it actually makes it way easier to remember. And where that comes from is SO represents sine, is opposite over hypotenuse. Ka represents that cos is adjacent over hypotenuse. And then toa represents that tan is opposite over adjacent. So that way you can just remember SOHCAHTOA, and then it can lead you to all your equations. So before we dive into actually using these, we're going to quickly do a few practice exercises with sine, cos, and tan. So what we're going to start by doing is we're going to evaluate these to 4 decimal places. When we type in tan sine, or cos of an angle, we're going to get these little decimal numbers. And when we have all of these decimals, to avoid rounding error, we need to keep a lot of decimals. So we usually say about 4. So when we do evaluate tan 25, in your calculator, I want you to literally type in tan 25. And you should get 0.4663. Now, if you got an error when you typed this in or nothing happened, you may need to type in 25 tan. So you may need to type it in backwards. So that's your first thing to try. If you got an answer, but it's very different than mine, it's likely that your calculator's not on the right setting and it needs to be set to degrees. No matter what happens, if you do not get 0.4663, and as I go through this whole page, you're getting different numbers than me, please send me an email right away and I can help you out with your calculator, because if you're having calculator issues, this stuff will be really hard. So please email me as soon as possible. So we're going to do 2 more together. So sine 86, I'm literally just typing in the sine button and then the number 86 in my calculator. So you should get 0.9976, and I'm just rounding at the end there for 4 decimal places. And finally, we'll do this last one together, and I'm just literally typing in cosine 45, and I get 0.7071. So there's 3 more here for you to try on your own. Give them a try and then check your answers on Classroom. So next, we've done where we take tan of an angle or sine of an angle, but sometimes you're given the decimal and you need to find out what that angle originally was. So basically what we're trying to do is we're trying to undo tan. Kind of like how when we want to undo multiplication, we do the opposite, which is division, or when we want to undo subtraction, we do the opposite, which is addition. Same idea here. I have tan of an angle, and I want to undo it. And how we do that is we use the tan inverse button. And if you look on your calculator, usually the tan, sine, and cos inverse buttons live in tiny writing on top of our sine, cos, and tan buttons. And how you get to the teeny writing is you have to click shift or second function. Again, if you're having any issues finding these values or you're typing it in and you're just not getting the right answer, please let me know as soon as possible so I can help you. So now what I'm going to do is I'm literally just going to type in tan inverse of 1.1918. And then we get 50 degrees. For our angles, we're just going to round it to the nearest degree, so whole numbers. So let's try a couple more together. So for this one, we have that sine y is equal to 0.9781. So in order to just get plain y all by itself, I need to undo the sign. So to do that, I use my sine inverse of 0.9781. And when I type that into my calculator, I will get 78 degrees. Next, for C, we have cos A equals 0.0349. So in order to get A all by itself, I just need to undo the cos. So that's what that cosine inverse does, is it undoes it. So I'm going to do cos inverse of 0.0349, and that will give me 88 degrees. And our last one here, sine B is 0.1788. So we just want plain B by itself. So we need to undo the sign by using sine inverse of 0.1788. So we get 0.178. We will get 10 degrees. Okay, so those are really all the skills we need to get started on some examples. So, how do we even use these? What is the point of this? The first examples we're going to go through are how to find a side length. So, when we're given a right angle triangle, we have an angle, we have maybe a side, but we need to find another side. These are the steps that you will take. So the first thing we're going to do is you're going to circle the angle you're given. And when I mean angle you're given, you cannot circle the right angle. It has to be one of the other ones. So we circle this angle we're given here. And now we're going to label our triangle based off that angle. So the first thing we're going to do is label the hypotenuse. And my hypotenuse is always right across from my right angle. So I'm going to label an H. And then I'm going to label the side with the Y on it. So because it's right across from my angle, that's my opposite side. And we only label the sides that have stuff on it just to avoid us from getting confused, or the side we're looking for. So it does tell us we're using the sine ratio, but how we know that is that we have an O and an H written because we're looking for O and we have H. So if I scroll up here to my equations, this is the only one with O and H. It's the only one that has that combination. So that's how I know I have to use sine. So let's write out our whole equation. So we have sine x equals opposite over hypotenuse. And let's fill in our values. So the angle we circled goes in for x. We labeled y as O, so we're just going to sub that in. And then h we said was 15. So now we want to get y all by itself. So 15 is currently being divided, so we'll multiply by 15 on this side, and we'll multiply by 15 on this side. So we're left with 15 times sine 34 equals y. And now I'm just going to type that right into my calculator. So we will get that 8.4 centimeters is equal to y. And that's it. So let's try another one all together. Our next triangle over here, we're going to use the cosine ratio this time to solve for z. So we'll start by circling the angle that we're given. Next, we're going to label our triangle, and we only label the sides that we're looking for or the sides that have values. So the first one we'll label is our hypotenuse, which is right across from that right angle. So we write an H. Next, we need to label that side with the 3. So because this side is right beside the 29, we know that this is our adjacent side. So if I look at my equations, the only equation that has A and H is cosine. So now we can write out our whole cosine equation. Cos x equals adjacent over hypotenuse. And now let's fill in our values. So x is the angle we circled, which in this case is 29. Our adjacent side is 3 meters long, and our hypotenuse is z, and we don't know it. So this one is a little trickier because of the z being in the denominator. So let's start by getting rid of z in that denominator. So in order to do that, I'm going to multiply that side by z, and I'm going to multiply this side by z. So now I have z cosine of 29 equals 3. Now I still want to get z all by itself, so I'm just going to divide this side by cosine of 29 and this side by cosine of 29. So I'm left with z equals 3 divided by the cosine of 29. And now I just put that right in my calculator. And it gives me 3.4 meters. And the last thing I always want to do is I want to look at my answer and then look at the other values that are on the triangle and see if my answer is in a similar neighborhood of the other ones. So that example is probably about as hard as this stuff gets for finding sides. So the next one is done for you. Give it a try on your own and then double check your answer with this one. Okay, so we found some sides. Now let's find some angles. So when we're finding an angle, the setup is very, very similar. The first few steps are exactly the same. The only thing that changes are steps near the end. So all the steps are listed for you there, but I find it's easier just to learn by an example. So for this example, we're going to use the sine ratio to solve for angle theta. So very often, angles are denoted by a Greek letter. And if you go online and you're looking up Khan Academy videos or Purple Math or Wolfram Alpha, something like that, you'll often see Greek letters, especially theta, for our angles. So I wanted to do an example like that so you had saw it before. So as usual, we circle our angle and then we label our triangle. So again, our hypotenuse is directly across from the right angle. Then my 33 is directly across from the angle I circled. So that is my opposite. Now it's telling me I need to use sine, but I also know it's sine because I only have O and H. So let's set up our sine equation. So let's fill in our values. So in this case, our angle isn't a number, it's theta. So let's just draw a little theta there. Our opposite side is 33 centimeters long, and our hypotenuse is 41 centimeters long. So now what I'm going to do is in my calculator, I'm going to change 33 over 41 into a decimal. And I do it by typing in 33 divided by 41 into my calculator. So now I have that sine theta equals 0.8049. So that number does not make any sense for an angle. Usually our angles are above 2. Not always, but that's usually a good benchmark to know if you've forgotten a step. So that is our sign that we have to do something else. And we just want theta all by itself. We don't want sine theta. So just like before, in order to get just plain theta, we have to undo that sign. So we're going to use that sine inverse again. So let's just type that into our calculator. Sine inverse of 0.8049, and that will give us 54 degrees. Let's try another one together. So for our next one, we're going to use the cosine ratio to solve for angle x. So the first thing we do is we circle our angle, and then we label our triangle. So the side right across from the right angle is our hypotenuse. And the side with this 9 that's touching our angle is called our adjacent. So because I have A and H, I know I'm using cosine, and it obviously tells me, but I also want us to practice that, and we'll practice more of it later, is figuring out which one to use. So let's write out our whole cosine equation. So we have cosine of x is equal to adjacent over hypotenuse. And now we fill in our values. So in this case, our angle is still x, so we can just leave that. The length of our adjacent side is 9 meters, and the length of the hypotenuse is 12 meters. So now what I'm going to do is I'm just going to divide 9 by 12 in my calculator to get a decimal. So 9 divided by 12 will give me 0.75. And that doesn't make any sense for an angle. It's way too small, and it's very unlikely that that's the right answer. So we need to do one more step. And in this case, we have cosine of x. So we need to undo that cosine to get x all by itself. So we're going to use our cos inverse to undo the cosine. So that will give us 41 degrees. So that is our angle value. So the last one down here has been done, but give it a try on your own to make sure you got the right answer. All of the homework is attached here, and the solutions have been posted on Classroom, so you can go through that. And again, if you are getting wrong answers for some reason, and no matter how much you type into your calculator, it's not right, there's probably a wrong setting on your calculator or you're typing it in wrong, so please let me know as soon as absolutely possible.